The next question of ours is a really important problem which involves a lot of concepts of straight line as well as pair of straight lines. We have to show that the orthocenter of the triangle, which is formed by these two lines and the line Lx plus My equals 1, is given by x by L equals y by m equals this thing. Now in order to proceed with this problem, let us first make the triangle. Let us say the vertex are A, B and C. This is perpendicular AD and this is the altitude BE. BC is given by Lx plus My equals 1. Let us say ax square plus 2hxy plus by square equals 0 represents the line y equals m1x and y equals m2x. So clearly our point A becomes 0, 0. Now we know that m1 plus m2 equals minus 2h upon b and m1 m2 equals a upon b. Now any line AD or the altitude AD passing through origin will have the equations y equals m dash x, and we know that the slope of BC is given by minus L upon m. So the slope of AD, which is perpendicular to BC, will be the negative reciprocal equal to m by L. So putting the value of m dash as m by L, we get equation of AB, or the equation of AD rather, as y equals mx by L. Now our orthocenter O, which is lying on AD, will be given by x upon L equals y upon m. Let us say this ratio equals to k. So in order to find the coordinates of x and y, or the coordinates of orthocenter, we just need to find the value of this constant k. Let us read out a triangle again. A, B, C, 0, 0, Lx plus My equals 1, y is equal to m2x, y equals m1x, and this was our orthocenter O. On solving the line AB and BC, we can very easily get the coordinates of point B. So solving y equals m1x and Lx plus My equals 1, we get the coordinates of point B as 1 upon L plus mm1 upon m1 upon L plus mm1. Now we know the slope of AC as m2. So the slope of BE, which is perpendicular to AC, will be equal to the negative reciprocal, which will be equal to minus 1 upon m2. So we know the point B, we know the slope of BE, so we can very easily write the equation of AB. The equation of BE rather, we can write the equation of BE as y minus m1 upon L plus mm1 equals minus 1 upon m2 times x minus 1 upon L plus mm1. Now we know that our orthocenter, which was given by x equals kl and y equals km, lies on the equation BE, or rather the line BE, and this is the equation of line BE. So satisfying the point KL, comma KM in this given line, we get KM minus M1 upon L plus MM1 equals minus 1 upon M2 times x minus 1 upon L plus MM1. And instead of this x, we can substitute the coordinates, x coordinate of the orthocenter as KL. So on solving this equation, we get the value of k as 1 plus m1 m2 upon L plus mm1 into L plus mm2. Now we just need to put in the values of m1 plus m2 and m1 m2. We know k is equal to 1 plus m1 m2 upon L square plus Lm times m1 plus m2 plus m square m1 m2, and we know that m1 plus m2 was equal to minus 2h upon b and m1 m2 was equal to a upon b. So we get the value of k as 1 plus a upon b divided by L square plus m square times a upon b plus Lm times minus 2h upon b. On simplifying and rearranging the terms, we get k equals a plus b upon am square minus 2h Lm plus bl square. On putting the value of k in this equation, we get x upon L equals y upon m equals to this whole value, and this was the result which we needed to prove.